Good day, ladies and gents. We're going to be doing day 11, partitioning, weighted average, and logic. All right, so there's a couple of things that we have to go over. First of all, let's talk about partitioning and weighted average. Okay, so I'm going to zoom out a little bit. So basically what's happening is we're trying to find where this fulcrum is. The fulcrum is to keep it balanced. That's what we're trying to figure out. So if it was like 2 to 2, it'd be right here, right? Now, if I made this 3 over here, in order for this to be balanced, see right now if that fulcrum was right here, it would fall because these are heavier, right? So we want to move this closer to the heavy side. If we move it closer to the heavy side, now it's going to stay balanced. And that's what we're trying to figure out. The location of this fulcrum is what we're looking for. Okay, so depending on the situation, so this is the weight. This right here is called the weight. This right here is not the weight. This right here, this distance right here is going to be the ratio. So the stick is the ratio, and the die, this all this dice right here, this is the weight. So weight, ratio, and this right here is the location of the fulcrum. So that is what the answer would be. All right, so in this case right here, for number one, so number one, we have, and I'll zoom in just in case you can't read that. It says, y, find y on mn such that the ratio ym to yn is 1 to 3. All right, so this is what's happening. We don't know what these are right now, but the ratio right here is 1 to 3. So 1 to 3. So that means that we have 1, and then the bigger part right here, 3, is over here. So this is 1, this is 3. So, and I'll put this on my paper. So this is a distance of 1, and this is a distance of 3. That's what's going on right now. So a distance of 1, and this is a distance of 3. All right, so that's what's happening right now. Now, the weight, that is the question. So the weight, now, a lot of people accidentally put put 1 then 3, but if we do that, that will definitely fall over, right? That's not correct. So we put a weight of 3 right here, and the fulcrum is, see, so what really needs to happen is these two need to switch. That makes more sense. We always need to be closer to the heavier side. So the weight. So this right here, this is 3, and this right here is 1, and that is the weight. So that's what's happening right there. So the fulcrum is right here, the heavier part, the weight is here. Now the ratio is the stick, and the weight are the dice. Okay, so let's zoom in here. All right, so this is what we have. So this is where M is, and this is where N is. All right, fabulous. All right, so basically this was happening. What we're going to do is, we have 3 M's. So now that we have the picture down, everything else should fall into place. There are 3 M's, 1, 2, 3, and there's 1 N. Boom. All right, so let's actually write down those coordinates. M is at -6, -4. And there are 3 of those. N, it's 6, 4. And there's only 1 of them. So all we have to do is add and divide by the total. That's all we have to do. Okay, so if we add all these together, so I'll show you my calculator so you can see what's going on in my head. So I'm doing -6 plus -6 plus -6, and then plus a +6, and I get -12. So all I did was add it, and now I'm dividing by the total. So how many are there? There are 4. There were 4. So we're going to divide by 4. That's where that number came from, right there. So we're going to divide by 4, and we get -3. All right, now we're going to do the same thing to the y's. We're going to add all those together. So -4 plus -4 plus -4 plus a +4. We get -8, and we're going to divide by the total, which is 4. If you don't want total, maybe like how many there are. Total number, I guess you can say. All right, so we got that. So -8 divided by 4, and we get -2. All right, so that right there is our coordinate, and that is where the fulcrum is. Maybe I should actually look up how to spell that. So look that up real quick. Fulcrum. Yep, it was a U. Okay, cool.
According to study.com, the fulcrum is the...
Yep. Okay, so now, if we put this there, so first of all, -3, -2 is right here, and that's where the fulcrum would be, and that's our answer. That's it. So that's -3, -2, and that's it. And that is our answer for number 1. All right, number 2, we're going to do the same thing. All right, so here we go. So -2, they actually told us what the weight was. So A has a weight of 2, and B has a weight of 3. So that's nice. So there are 2 A's, 1, 2, and there are 3 B's, 1, 2, 3. So there was no need to think about this. They already told us what the weight was. So now where is A? Oh, it's just -3. So -3, -3, and B is at 2, 2, 2. All right, so it's just like what we did a second ago. Instead of coordinates, we just have single numbers. So we're going to add all those together. So I'm going to show you what's going on in my head. So -3 plus -3 plus 2 plus 2 plus 2. We get 0. And now we're going to divide. We divide that by how many there are, and there are 5. So divide by 5. And we pop out with the number 0. So the fulcrum would be right here, which is closer to the heavier part, which is always going to be true. And that's 0, and the answer was D. Very nice. All right, let's keep going. All right, now for number 3. All right, so for number 3, here are the basic rules. For if you have A, then B. All right, so if you have any statement, if A, then B, then the converse, basically you would just switch those. So converse, it would just be BA. Inverse, it would just be not A, not B. And then contrapositive, just explain a little better what those mean. Contrapositives is you do both of those things. So it would be not B, not A. So you switch them and you put in the words not. So not B, not A. All right, so that's what that little squiggly means. All right, so in this case, so they said to write the converse, the inverse, and the contrapositive, determine whether it's true or false. We're just going to cut that part out. Because there's just too many options at this moment. Like, I can always think of a counterexample, so we're just going to cut that out. So just put that out. And all I want you to do is think of one counterexample. Just think of one. If you can think of one counterexample, I'm happy. All right, so Kaylee is waiting to board an airplane. Over the speaker, she hears the flight attendant say, "If you are seated in rows 10 through 20, you may board now." All right, so the original statement. So for the original statement, all right, is if you are seated, so if you are seated in 10 through 20, then you may board. Right? That's the original. All right, so this right here, this is A. This is B. All right, so that's the basic gist. This is A, this is B. So all we're going to do is switch these. So converse would be if you board then you are 10 through 20. And it was supposed to be like row. Then you are seated in 10 through 20, right? Okay, so inverse is you go back to the original and you put in the words not. So if not A. So if you are not row 10 through 20, then you are not boarding. Okay, and then right here for contrapositive, you switch them and you put in the words not. So if you are not boarding, then you are not in row 10 through 20. All right, so now that we have those, so those are all of our answers. Now let's think if we can think of a counter example. All right, so let's do just one counter example. If you are boarding, then you are in rows 10 through 20. What would be a chance that you were boarding? So if you were boarding, okay, so you are boarding. So this part's always true. What would disprove this one? So if you're not boarding, you are in rows. So we're boarding, but you're not in rows 10 through 20. Why would you be boarding then? Okay, here is a counterexample. So here's a counterexample. A counterexample would be you're a flight attendant. You just have to be on the plane. That's a good reason, right? The flight attendant. That is a counterexample. So that right there is a counterexample. All right, let's see if we can think of a counterexample for this. If you are not in row 10 through 20, then you are not boarding. So you are not in row 10 through 20. All right, so let's say we're in row maybe 3. Or so let's say we're in row 3 or something. Why are you not boarding? So I don't know. Let's see. Well, that's definitely true because we're not supposed to. So let's see. What else? Why? What would be another reason? That's about it. It's like I can. So that's just false. That's just straight up false. So yeah. So row 3. We're in row 3. That's why we're not boarding. Okay, that's a counterexample. If you are not boarding, then you are not in row 10 through 20. Okay, so what would be a reason why we are not boarding? But we are in row 10. Like so this part, so both parts, and you are not in, so we're in row 3. What's the reason we're not boarding? If you are not boarding and you are not in row, so it's basically what would make this false? We're in the bathroom. So is that the reason why we're not boarding? No, I'm in the bathroom, so I'm just late. So those are just counter examples, but just put that out there. All right, awesome. All right, let's keep going. All right, number 4. Okay, so number 4, determine if it's inductive or deductive. Okay, so this is where it starts getting a little interesting. Okay, so you need to know what these are. So inductive and deductive. Let's talk about this for a second. So basically, if you want, you can take a picture of this, what these reasonings are. Put that out there right there. All right, so deductive. Deductive reasoning is the act of backing up a generalized statement with specific scenarios. And here's a list of examples. Inductive is inductive reasoning is the act of making generalized conclusions based off specific scenarios. All right, so with that, deductive, you have a theory, hypothesis, observation, and then you make a confirmation. Basically, you're starting with information, and then you think of pattern, and then basically you go down to a theory. So you're making theory. Inductive is taking a theory, you have a hypothesis, observation, and then confirmation. So basically, you take a generalization. To be deductive, then you can make specific instance. Whereas inductive, you take basically an observation that you saw. So you're starting with an observation and you're going up to the theory. That's what's happening. So these are just, see how they're reversing, basically. So that's the basic gist. So starting with your own personal observation and making a rule, whereas here deductive, you have a rule and you're applying it to a specific instance. So that's what's happening right there. All right, so now let's actually apply this to this. All right, if Emilio decides to go to a concert tonight, then he will miss the football practice. Tonight, Emilio went to a concert. Emilio missed the practice. All right, so that one, that would be deductive. That would be deductive. All right. A dental assistant notices that a patient has never been on time. All right. So you notice something. So this right there isn't a personal observation. So this is a personal observation. She concludes that the patient will be late to the next thing. So she starts with an observation and she's going to a rule. She's making a rule out of this. So that is inductive. All right. Okay. And then this one. Every Wednesday, JC's mother calls. Today is Wednesday. So JC concludes that her mother will call. So that right there is deductive. So that right there, that is deductive. So basically, we notice some, so this is a rule, and now she is applying it to this particular instance, and that's deductive. All right, awesome. All right, so now the next thing, and the last thing. All right, so draw a valid conclusion from the given statements if possible. Now here's the important part. If possible. So there's a chance where it's not going to work. So that's very important. Then state whether the conclusion is the law of detachment or the law of syllogism. All right, so let's talk about that real quick. What are those two different things? So if you need to take a picture, go for it. Law of detachment. Law of detachment is if P, then Q. So if the first part's true, then the next part will be true. All right, so that's just detached. It's a rule. Boom, you're there. Syllogism is basically you cut out the middleman, or the transitive property is another way. So if P, then Q, and then Q, then P, then P, then Q. So if the first part is true, then the second part's true. If the second part is true, then the third part is true. So take, if 1 equals 2 and 2 equals 3, then 1 would also equal 3. That's basically the main instance. All right, so here we go. So if a figure is a square, then, if the figure is a square, then all the sides are congruent. Okay, so figure ABC is a square. So what conclusion can we make? All right, so conclusion. So conclusion would be, so we now know, so we know that's a square. So what's the next thing we can say? Then all sides of A, B, C, D are congruent. What rule did we use? Okay, so if B, then A, or sorry, if A, then B, whatever, then that right there is detachment. All right. If you are an athlete, then you enjoy sports. If you are competitive, then you enjoy sport. Okay, there was no connection right there. There was no connection going from one to the other, and now if these two were switched, then I could say that. So if this was right here and this one was right here, then I could say yes, that I could do a new rule, but there's no direct hopping, so there is no conclusion. However, if these two were switched, then I could have done something. All right, so this one right here has a typo. Typo. Can everyone please change this to the letter F? Everyone change that to the letter F. Sorry about that. All right, so for this one, if Jeremiah completes a course with a grade in F, then he will receive no credit. If Jeremiah does not receive credit, then he will have to take the course again. All right, so if A, then B. If B, then C, right? So we can just cut out the middleman. So here's the conclusion. So the conclusion is so we're basically cutting out the middleman. So if completes, so if Jeremiah equals an F, then cut out the middleman, he will take course again. Which no one in our classes would ever, no one would dare do that. Everyone's going to rock this, right? Okay, now what did we use? We used syllogism. We cut out the middleman, right? And that is it for the day. So I'll zoom out just in case anyone needs to see the whole shebang on this one, this lovely little assignment here. Hope that helped you guys out and have a great and wonderful day.